So I'm a software developer, and I assume that most of you are software developers too. And yet I would like to talk about deployment and monitoring. So this may seem a bit strange. But deployment and monitoring are necessary steps in order for the software that we develop to become useful to people. If we develop software and it stays on our development machine, it isn't bringing any profit to anyone. We also may think as developers that these topics are less exciting than actually creating the software. But we should not only think about ourselves, we should also think about our employers and about our end users. And for our end users, it doesn't matter much if our jobs are exciting, but it does matter a lot if we can deliver software which solves some problem of theirs, if we deliver software which works for them. And many of us are using some kind of agile methodology right now, whether it be Scrum or anything else. And of course, agility means caring for the customer. And if you recall the Agile Manifesto, one of the important keywords which appear there is working software. In practice, this most often means a focus on software quality, on technical excellence, and on testing. So there are lots of presentations about testing, and many people even use test-driven development, or at least claim they do. And this is all very good. But we should remember that even if we have 1 million tests, software with passing tests does not by itself constitute working software. It only becomes working software once it's deployed to some machine where our end users can run it, and our company can benefit from it too. So deployment is important, it matters, because it means taking that last step from software with passing tests to working software. And monitoring matters because it is about checking that the software really is working in production, and it is about making sure that it keeps working, because the environment in which our application works might change, the network might change, or the behavior of our users might change. So what is working now might stop working tomorrow, and we want to know about it before something bad happens. So without proper monitoring in place, if something goes wrong, you won't even know what hit you. And sooner or later, something will go wrong. It's certain. So you better be prepared. When I started my first job as a software developer, I was quite surprised to see that when it came time to deploy the code that we had written, quite often our team leader would do it by himself. And even if he was not doing it himself, he was always very interested in how it was going. He wanted us to learn how to do it properly. So it seemed to be an important topic for him. And for me, as a young developer, it was quite surprising because there was this awesome, experienced developer, and he was spending his time on something which I found not interesting at all. But later I saw a similar pattern at other teams, that team leaders, that senior developers were the driving force behind work related to deployment. They wanted their teams to learn how to automate tasks, how to deploy their applications, how to monitor them. So in hindsight, I think I should not have been so surprised. And I think there are several reasons for that. So one is that deployment may not be so exciting, but it is something that needs to be done. And it is a sign of maturity and of taking responsibility for the project to do something which is necessary, even if it's not as fun as other things. And it also is not as simple as it seems, because deploying an application, especially if you are doing it for the first time, if you are preparing some general system which will help you automate tasks later on, requires knowledge not only of your system, but also of your system surroundings, of the dependencies of your system. So many factors come into account, and it takes some experience to be able to foresee what kind of issues may appear and how to handle them. And I also think that sometimes deployment is a kind of no man's land. Because if you are developing your application, you have some problem with how to implement something, then most of the time you can ask your fellow developers, other members of your team, how to do it, and usually they can help you. And if you do not know what to implement, what functionality your application should have, how it should behave, then you can ask business people, perhaps your product owner, and they can help. But with deployment, you may find that you are on your own, and there are few people who can really help you. So dealing with a situation where you have to do something and there is little help also requires a kind of stamina, so to say, a kind of responsibility. So that's also a trait which I think may identify senior people and leaders. So at this point, you may be asking yourself, well, we have administrators, so why don't they do all this stuff? And I think that you should cooperate with your administrators. You should try to be friends with them. And you should share knowledge, because often they have a lot of knowledge about hardware, about operating systems, about networks, about databases. But there are certain things with which they cannot help you. And first of all, they do not know your application. So, for example, when it comes to monitoring, they might be able to set up some very simple generic probe which just pings your application to see if it's alive. But they won't be able to set up any complex monitoring because they don't know the details of your application. They don't know its dependencies. They don't know where the performance bottlenecks are. This is something that your development team knows. And if you are developing your application actively, then there will be lots of things going on. Your application will be changing all the time. So again, someone who is not on your team probably won't be able to stay up to date and keep the pace of change and know the current state of things. So in the end, you must share work with your operations or with your administrators. You should exchange knowledge, but both you and they have some work to do. You can't skip it. You can't move all this work to them. So deployment is one of those things which you hardly see that they are even there if they work correctly. But if they don't, it can be a major source of pain. Because if it is not going well, and your team is working on it, it can be a source of great frustration. It can cause you to waste a lot of time, which would be better spent developing. And of course, your developers would be much more happy if they spend time coding than deploying. And if you are really unlucky, you might even miss some kind of a deadline, because you may have developed your software and your tests pass, and they work on your workstations. But if you are not able to bring your software to production, to the machines from which your users will be running it, then you are not generating any value for the company. The software is not working from their point of view. So you can think of learning about deployment as of going to the dentist. So you inflict a little bit of pain on yourself right now in order to spare yourself from much more pain later on. But on a more positive note, I also think that knowing how to deploy your applications will make you a better developer, because it will allow you to take care of your application through its whole life cycle, so that you do not say, I wrote my code and my tests passed, so my work here is done. And now let's leave it to others. So I think you should follow your application also through this last step and make sure that it really is running, that it is generating business value for your company, and that it is useful to your end users. And the first thing you should probably do is to automate your deployment. because manual deployment is slow. It's also error-prone, because we are humans and we make errors. And it can be really frustrating if it is not going well. And last but not least, it does not scale. So it may work reasonably well if you have 2 or 3 or 5 machines. But if you go to more, it just won't work. So my recommendation is that you use your continuous integration environment for deployment. You probably have, or at least you should have, a continuous integration environment anyway. And compared to, for example, running some kind of scripts from developers' machines, integrating with your CI environment has many advantages. Since it's a web application, it's operating system independent. So you do not have to worry about differences between developers' machines. And it's a single environment, so your builds can be easily reproduced. It's the same environment for everyone. And it also serves as a central storage point for the logs. So you know what has been deployed where. You have logs. Everyone can access them. So it's quite convenient. And there are many solutions, both open source solutions like Hudson and Travis, and many more or commercial offerings like Bamboo. So you have to deploy your application somewhere. And there are several choices, of which I will discuss 3. So these will be physical machines, virtual machines in the cloud, and cluster solutions such as Mesos. Physical machines are the simplest setup. So you either buy or rent physical boxes, which are located in some server room somewhere, and you can do whatever you want with them. So you install some operating system, you can use SSH to open a console, copy some jar files perhaps, run something, and essentially it works. And since there is no virtualization involved, for certain types of tasks, it may be also the fastest solution. Especially I/O-heavy applications such as databases may not work as well with virtualization as other kinds of applications. But as with anything related to performance, you have to check for yourself. So do not trust such advice blindly. And of course, since it is so simple, there is a very low barrier to entry. If you know basics of Linux, essentially you can do it. So you do not have to learn much in order to deploy in this way. But there are certain limitations, and the biggest problem is that it simply doesn't scale. If you want to add another box, then you have to order it at some manufacturer. Somebody has to go to a server room, put it in a rack, install it. It all takes time. And if suddenly you realize that actually you needed more memory in that machine, then somebody has to go, open the box, plug in the chip. It's also a slow process. There is also a wastage of resources, because perhaps your application needs 2.5 gigabytes of memory, but then you probably have to order a machine with 4 gigabytes. So a large part of that memory goes unused. So you might think, well, I don't want to waste resources like this, so perhaps I can install another application on the same box to use it better. But what you end up is, it's like a jigsaw puzzle. You have those small pieces which use some kind of resources, and you try to fit them together. And it easily leads to having several machines with completely different setups. It becomes a mess, and you have to worry about applications running on different ports so that there are no conflicts. And if you go above several machines, it's not maintainable. And in order to solve this problem, people came up with the cloud. And the cloud is a big buzzword. So depending on whom you ask, it may mean completely different things, or it even might be some marketing speak which does not mean anything at all. So for the purpose of this presentation, I will use the word cloud as a computing environment where you share resources by using virtualization so that your application instances are not bound to a specific physical box. It's as simple as that. And the simplest cloud-based solution, it's called infrastructure as a service. It consists of a set of physical machines, because in the end there must be some hardware to run stuff. And on those physical machines, you set up some virtual machines. And on those virtual machines, you install your software. So it's actually very simple, but it's very powerful. And the power comes from the fact that you can start and stop those machines at will with a few clicks in some configuration panel. So this allows you to start new instances quickly, and you can easily deploy new instances of your application. You also do not have to worry about resource usage, because the virtualization layer handles that. So you can just assign some arbitrary amount of memory to your virtual machines, and even if some of it goes unused, you do not worry, because it's virtual machines. So the virtualization software fills in those gaps. You do not have to do it by yourself. And you don't have to worry about port conflicts, because this kind of setup leads you to a very simple configuration. You simply install only a single application on a single virtual machine. So you do not worry about conflicting ports, and those machines have very simple setup. So essentially, those virtual machines behave just as physical machines. They still have names. You can SSH to such a machine, do whatever you want. But most of the time, you do not want to do anything. You will rather configure you will usually configure them to run a single application. And here you can see an example panel from OpenStack. That's one of the systems that we use at Allegro. This is how you start a virtual machine. So you just fill in a few fields. You give the machine a name. You choose the flavor, which means a combination of CPU, memory, and disk sizes. You choose an operating system image, and you click launch. So filling out this form takes about 30 seconds, and then perhaps you need to wait up to a few minutes for the machine to be ready to use. So compared to ordering a physical box and installing it in some rack in a server room, it's blazingly fast. And in the setup that we use Puppet. It's a configuration management software which allows you to easily set up a machine. So you can change configuration options, and you can install software based on a small configuration file. Another often used, another common solution is called Chef. And in this setup, if I prefix my machine's name with my application, then a Puppet configuration called my application will be used. So by using a certain name for the virtual machine, I also say what kind of configuration to use, what application to install. So it just takes a few minutes, and I have another instance of my application running. And if I decide that I don't need it anymore, I just click on the Destroy Instance button, and it goes away. So since we work with microservices, this is very convenient, because we often want to start new machines for new services which we create. And sometimes we want to just add more instances because, I don't know, because we expect more traffic due to some situation. And it really is convenient. And even though the concept is so simple, compared to physical machines, it's a completely different world. But we can go even a step further and run our application instances on a cluster. And in this configuration, we do not even think about virtual machines anymore. We think in terms of application instances. So we lose some control. There is no SSH because there are no virtual machines. There's only this, so to say, external machine, the host on which the cluster is running. But in this case, somebody else is managing it. And we trade some of this control for flexibility, because in this setup, it is even simpler to start instances. And for example, in Mesos, there is a REST API using which we can start instances or stop them. So we can create a kind of feedback loop that, for example, we detect that there is more traffic or that our applications are responding slower than usual. So we start more instances to handle this traffic. And this is possible, and these are very new possibilities, so to say. But it's a trade-off, again. We lose some things. We cannot SSH to those machines anymore. And this is an example panel. So here, I just say I want to have 2 or 10 or 50 instances of my application. And that's it. As you can see below, those instances are identified by some kind of UUIDs. So those are names you can't even pronounce it. But you don't care. You don't care about individual instances. You only care about the total number of instances which are running. So there are several solutions to choose from. And the choice is actually about a trade-off between how much time and work you want to invest in the beginning in order to learn the system, in order to learn how to configure it, in order how to manage this stuff, versus gains in flexibility and less time spent on deployment later on. So you should choose for yourself, because setup which is good for a company that needs to run 1,000 machines may not be good for a company which needs to run 5 machines. And of course, the other way around too. Virtualization gives us those great possibilities, this flexibility, but in certain situations, it may cause some performance issues. So for some applications like databases, which perform a lot of I/O operations, you might still think about physical machines, but you have to trade for yourself. Each case is different. And the environment in which you run your applications affects how you write those applications. You may have attended yesterday's presentation about Spring Boot Cloud. And as you see, there are certain challenges in cloud applications. So for example, you need some kind of discovery service so that all those instances which are created and destroyed at any moment know about each other so that they can communicate. And of course, there is no gain at all in being able to easily start 10 instances of your application if your application is not scalable. So if it's an application which only works well if there is 1 instance, then there is no gain in running 10 of them. In many applications, the database or some other kind of storage is a critical point, both from a performance and from a stability point of view. So your storage needs to be about as much distributed as your application. So if you run your application on some funky Mesos cluster with hundreds of instances and so on, but they all store their data in a single MySQL database running on a single box, then it won't work. So your storage must fit your application. And as always, use common sense, both when choosing your deployment environment and when configuring it. And of course, microservices are the topic of the day. And we use microservices at Allegro. And it's a good thing, but there are several buts. So essentially, you're not getting rid of complexity. Your applications are becoming simpler, but complexity is moved to the infrastructure. So if you decide to use microservices, you will have to deal more with network. Your applications will become useless without the network. And you will have to deal more with deployment and monitoring. So you should ask yourself if you can handle a single application, multi-application perfectly. If you can't, then exchanging one application for 20 or 50 separate small applications certainly won't help. So let's say you have already deployed your application, you have a perfect deployment system. So perhaps it would be good to set up some monitoring. And the question is, why should we do that? The shortest answer might be that you want to sleep well at night, because you want your application to work, to behave in a stable manner. So you want to know if your application is working, if it is working correctly, if it is working fast enough. Because in certain systems, if your application response times go up, then they might not be working at all as well. And you want to know what happened if something goes wrong. So there is a little gain in knowing that your application is down. You probably already know that because your customers told you and they are phoning your support and they're very angry. So you want to know what exactly happened. You want to be able to find that source of error. And monitoring is also necessary if you want to be serious about performance tuning, because artificial load tests in practice are very hard to perform. If you have a big complex system with lots of machines, it's close to impossible to set up a smaller scale test which will give you certainty that you can apply those results to the full scale environment also. So you need to run artificial tests, but you also have to monitor your production environment, and you want to monitor it both for knowing if things are going well right now and for predicting if something might be starting to happen. So you want to watch trends, and you might be able to identify issues before they become real problems. And those problems might have a source in your application, but they might also be caused by something external to it. So for example, your users might change their behavior, or some client of your application might suddenly start sending a new kind of requests. And this shows that deployment and monitoring are tied together, because if you have a flexible deployment environment, it makes reacting to change easier. So for example, if you detect that you would need more instances, then you can easily start them. So we can say that monitoring extends testing to the time after deployment. So it's a part of the same quest for technical excellence as writing tests for your application. It's just going a step further and going with your application also through those later stages in its life cycle. So how do we go about this monitoring thing in practice? At the lowest level, we want to monitor machines, because if something bad happens to your machine, no software can save it. So this is an example screen from an application called Zabbix, which can be used to monitor system parameters such as CPU usage, memory usage, free disk space. Depending on your application, you might also want to monitor network traffic or I/O throughput. Another popular solution is Nagios. And if you use virtualization and you manage your cluster yourself, then you have to do it at two levels, because you need to monitor both the virtual machines on which your applications are running and the physical machines on which your virtual machines are running. So you have two levels of machine monitoring. But the most interesting part is monitoring the application, because we're software developers, we develop applications, so that's where most of our interest lies. And there are several main classes of monitoring that you want to put in your application. So health checks are just binary probes. They just say if something is working or not. So the simplest probe you might want to set up is just a kind of a ping. An endpoint which just always returns OK and HTTP code 200. So if your monitoring application can reach that endpoint and retrieve this OK answer, there are chances that your application is working. But that's a very simple probe, and you may want to set up something more complex. For example, a probe which performs an artificial request. So it simulates a request which it might receive from a real user. So it might query the database, it might query some other services to go through all these paths through which normal requests go. And if this succeeds, there are pretty good chances that other calls, which come from real users this time, will also succeed. Metrics are performance parameters. So these are a series of numbers which tell us something about the performance of our applications. An example would be response times. So every once in a while, you query the application, and you check the response times. Of course, if you have a lot of requests, you do not want to know, at least in the beginning, you do not want to know about each individual request. You are more interested in statistics. So you may gather parameters such as a histogram. How many % of requests took what time? And those metrics can be gathered in two ways. So they can be pulled from the application. So the application may make available some endpoint, and then your monitoring system, such as Zabbix, might be pulling data from that endpoint. Or your application might be pushing this application to some system which gathers this data. An example would be Graphite. Most applications also have logging, so that's something you probably do anyway. You log events which are interesting in some way. And often you also want to log performance metrics, because metrics give you a statistical view. So you just want to look at a single number or several numbers, and from that make a decision if things are going well or not. But once in a while, you want to debug a particular issue. So a customer comes and they say, we have this request and it's taking so long. And then you want to look at an individual request. So that's where logging can help you. So here, instead of a statistical view, you have individual requests. You do not use them often, but if you do need to debug an issue, it can be very helpful. And an application which is monitored well may have lots of those metrics, because it's hard to describe complex behavior with a single number. So you may not want to scatter those logging and metric gathering instructions all over your code, but instead use something more generic. And this is where aspect-oriented programming can help. So with aspect-oriented programming, we can use, for example, an annotation. And on each method which we mark with this annotation will be timed. So we do not have to add code like start the timer, perform your business logic, stop the timer, log the result. We don't have to put this everywhere and mix logging and business logic. And of course, we do not want to reinvent the wheel. So it's a good idea to use something ready-made. And an example of a popular library for gathering metrics is Coda Hale metrics. Coda Hale is the name of the author of the library. So here is some method. It doesn't do anything interesting by itself, but it is marked with two annotations. And the first one is our custom annotation. I'll get back to it in a moment. And the second, this timed annotation, is a Coda Hale metrics annotation. And if you use Coda Hale metrics together with Spring Boot, you just put this annotation on your method, and this automatically causes your application to make available metrics about calls to this method. So you will know how much time this takes. You will get some statistics with just this single line. As you see, I'm using the name parameter. It's optional. I could have skipped it. And then the name of my metric would be based on the name of my method. But I do not want to do that, because then if I refactor code and I rename my method, then the name of the metric will change. And I might be using the name of this metric in several places. I might have some triggers set up so that email alerts are sent out when some warning level is exceeded. So I always want to use a constant name, which is not modified even if I refactor my code. And this annotation above, external service logging, that's an internal annotation that we use in our project. And it's used to do the same thing, but for logging. So by adding it, because all calls to this method to be logged, we'll see that this method was called, whether it succeeded or whether it threw an exception, and how long it took. So, and this information additionally is marked with a unique request ID. So since this request ID repeats through all logs in the system, we can easily connect the points, and we have all the data about a particular request. So if we see that this request took longer than expected, we can find all logs related to that request, and we can find which method call took so much time. And then we can tell if it was the database, or perhaps some external service, or perhaps it was even something in our own application. This is a REST client, and here you can see the results of creating such a metric. So these are some endpoints, and we can see that for post call, there were calls which resulted in 201 HTTP code. You see the number, you see the rate, and this is all generated automatically by Coda Hale metrics. And then we can connect to that endpoint, for example, using Zabbix or another system, and we can generate nice graphs. And these charts can tell us a lot about what is going on in the application. Because we can see trends, we can see if the response times are rising or falling, and if they're rising, then perhaps something has changed. Of course, there are also cycles, so in many applications, you will see this daily cycle that the number of requests goes down in the night and then rises during the day. But with some experience, by looking at such a chart, you can tell a lot about what is going on in the application. And if you don't like it, you might be able to easily tell what is the cause. You also see a horizontal dashed line here, and this is the trigger level. So if one of the response times exceeds 100 milliseconds, an alert will be triggered, and somebody will be informed, and we have to do something about it. We'll get to it in a moment. Logging, probably everybody does it, and you have written code like this once in a while. I have, and this is a perfect case for replacing with aspect-oriented programming. So you have this prolog code, you log that you're about to do something, and then if an error happened, you log that there was an error. Additionally, you might log the times. So you do not want to repeat this code over and over again and mix it with your business logic. It's better to do it in one place and automatically amend all methods of interest with this logging code using aspect-oriented programming. Since we have a cluster, we have deployed lots of instances, and we log. And if we just logged to a file, we would be in trouble, because we would have to log to 10 or 20 machines to find out where the log entry which interests us can be found. So in this case, we prefer to run remote logging. We can use a service as Logstash, and all logs are pushed to that server over the network. This server can gather all the logs, it can index them, and it can make them searchable in applications such as Kibana, which uses flexible search underneath, Elasticsearch, sorry. And as a matter of fact, many virtual machines which we set up have 0 disk space. We do not use local logging. We send logs over the network. So there is a disadvantage that this depends on the network. If you can't push your logs over the network, then you don't have logs, so you don't even know what went wrong. This is an issue, but in practice, it happens very rarely. And if you have a microservice-based architecture, you are dependent on your network anyway. Without the network, it simply doesn't work. So this infrastructure has to be in place, and it has to work anyway. And the advantages are much greater than potential issues. So here in this panel, you can enter queries, and there is recently quite an advanced syntax for searching those logs. Kibana also generates for you charts. So, for example, you can enter a query such as level semicolon error, and you get a chart of how many logs at error level there were. And you can find those logs regardless of on which server they originated. So once you get once you have more than a few servers, it's a must, and it's really convenient. And as I said, you may have 10 or 20 or 50 or 100 metrics in your application. If it's a critical system, it's not a problem. It's better to have too many than too few. And you can prepare a dashboard. That's a web page on which you present those charts which show you metrics. And if you do it well, then a single glance at such a dashboard of somebody who knows the application can usually tell if things are going well, and if they are not, then where the cause lies. As you see, there is a scroll bar, so this goes on and on. There are many charts, and by looking at them, I can usually tell if this application is working as expected. So since you want your application to work as much of the time as possible, then of course you do not want to wait for somebody to look at a chart and identify a problem. You want to alert them if something goes wrong. And for this purpose, you can set up alerts or triggers. So most of these triggers are just simple relations, such as if the 95th percentile of the response time exceeds 100 milliseconds, then trigger an alert. And of course, if your health check goes down, then trigger an alert. Usually they can have several levels. So you may have a critical alert if your application goes down completely, and a slightly lighter trigger if only the response times rise, but the application seems to still be working. Of course, you have to notify someone, and there are many channels. So you can use email or short messages, text messages sent to your phone, or you may even have a voice synthesizer call you and tell you that there is a problem on a machine. Zabbix has alerts built in, and there are also external systems like Cabot and commercial offerings like PagerDuty. But then, of course, you have to know whom to call and what do you expect them to do. So your team needs to have a schedule of who is on duty. But first, you have to identify your business needs, because an application which is critical for a big company may need 24-hour per day support. So even if anything happens in the middle of the night, somebody has to get up and fix it. But if it's a less critical system, then perhaps you do not need that. Perhaps you only need support during working hours, or perhaps you need support until 8 p.m. and you assume that later on there is little traffic and it doesn't matter and can wait until the morning. Of course, it's again a trade-off of how good support you need for your application and how many people you want to put on it and how much you want to pay them for that. But you should know what to expect. You should know who is on duty and how they should react to an issue. Do they need to, I don't know, fix the problem within 15 minutes, or perhaps it can wait an hour? It's good to identify that before serious issues happen so that there are no misunderstandings later on. When you set up triggers, usually you start with some business assumptions. So for example, you say, it would be very good if this application was able to respond within 100 milliseconds. But so you may set up a trigger for, I don't know, you want 95% of your requests to be handled within 100 milliseconds, and then you start getting alerts. Because it so happens that 95% of your requests are handled within 110 milliseconds. So you have to decide. Either you may invest some resources and spend some time, or perhaps you need to use more hardware so that you can actually get to that target value of 100 milliseconds. But then perhaps it's not worth the fuss. Perhaps you can talk to your business and they can say, okay, well, we just thought of 100 milliseconds because it's a nice round number, but 110 or 120 are also fine. Certainly the worst thing you can do is pretending. That is, having a trigger level at 100 milliseconds, even though you know that you cannot keep it. Because then you will get a ton of false alerts, and you will learn to ignore them. And then if something really bad does happen, it will just get lost in this stream of false alerts. And you might miss something really important, like your application going down completely. So be serious about it. If you see that you cannot keep the target you set, either do something about it quickly or fix the target. Do not go on fooling yourself and ignoring false alerts. You should probably also somehow formalize the performance requirements of your application. It's called an SLA, or a service level agreement. And that's a document where you say what your users can expect from you. It does not have to be very formal. It may be 2 lines, like 95% of all requests are handled within 100 milliseconds. It's simple. It may be just fine. But it's important to set expectations, because this way your users, not necessarily your end users, it might be the business users inside your company, they will know what to expect. And you will know what is expected of you. Because if you cannot say that your application is working fast or if it's working slow if you do not define what fast or slow mean. So it may be a very simple definition, but you should have one. This way people will know what to expect from you, and you will know at what you are striving, what level you consider acceptable, and what level you think needs fixing. This is an example of trigger setup in Cabot. It's a very simple trigger. Sometimes you need more complex expressions, but it's rare. Most of the time it looks like just like this. Trigger type is greater than, value is 100 milliseconds. The value has to be checked once per minute. The check is active, and it's an error. So it's a middle level. It's not critical, but it's not just a warning. Certain systems, like Zabbix and Graphite, allow you to write very complex expressions, but it's not often needed. So we have some tools for monitoring stuff, and here's the stuff we might be interested in monitoring. And the funny thing is that, first of all, you should monitor your monitoring system itself, because it's a complex system. It may have some non-trivial performance requirements, and it might break. And of course, if you use your monitoring system to measure your SLA, then you cannot get a higher SLA from it than the monitoring system itself has. So if your monitoring system is available only 99% of the time, then there is no way that you can get from it measured availability of some system at 99.9%. This will be the weakest link, and you can't get any higher than that. So your monitoring system should actually be the most stable component in your whole system. These are the machine parameters: CPU, RAM, disk, which I mentioned, health checks. If it's a REST service, then of course HTTP error codes, because it doesn't help if your application is handling user requests very fast if it's returning errors all the time. Response times from your application. And it is important that you measure the times it takes to contact all external resources like databases or other services. Because if you only measure the total response times, then you know that your application is slow. If you measure the partial times, then you know which part is slow. And this allows you to dig further, to identify the problem and to fix it. So it's very important. It may mean that the number of probes that you have configured grows, but it really helps. This is a broad topic in itself. I will only mention it. Never trust averages. You may measure response times, and you may get a very nice average, but that does not mean that your system is fast. Because the distribution of response times is usually not Gaussian. So this means that it may happen, and I have seen this in practice, that, for example, you have an average response time of 5 milliseconds, but once in a while you get requests which take 2 seconds to complete. So that's 3 orders of magnitude. So it may seem strange, but it really happens. That's the characteristic of those systems. So you always need to measure times in the whole histogram. You need to take the average, you need to take the median, you need to take the 90th percentile. So the 90th percentile is the time within which 90% of your requests complete. And the 95th percentile, and the 99th percentile, perhaps the 99.9th percentile. And only when you have those numbers, you can approximate the shape of the distribution of the response times. And often you will find that the low percentiles are all very nice, but one request in 100 takes a very, very long time. So if you only look at the average, you may be very happy, but it may be ungrounded. There is a very nice presentation called Taming the Nines by Ariel Weisberg, and I recommend that you watch it if you are interested in performance. If you want to find it on YouTube, you have to type it like here, so you have to type it with the digit 9 and S, otherwise you won't find it. But it's very interesting, and there are some surprising consequences. But the short message is, never trust an average. Okay, so this was it. If I was to summarize this whole presentation in one sentence, it would be that deployment and monitoring are about creating working software. It's just another step after tests in ensuring that you have delivered software which works well. And I think that you should care, because learning about deployment and monitoring will allow you to be a better developer. It will allow you to take care of your application not only into the stage of testing, but also beyond. And it will allow you to deliver business value for your company and to deliver software which is useful to your end users. It will allow you to sleep well at night, because you will know what is going on in your application. It will allow you to avoid stress and frustration on the team because of failed deployments and issues related to that. And if your system is performance critical, it will allow you to know what is going on inside. It will allow you to measure actual performance to predict potential issues in the future. And last but not least, I think it can actually be quite an interesting thing. Thank you. And if you have any questions, I will try to answer them.
Here?
Yes?
So for the Kibana Elasticsearch stuff,
Mm-hmm.
did you encounter any performance issues? Do you have numbers what was the throughput were to send to the Elasticsearch? Any problems there?
Okay, so the question was, when we use Kibana and Elasticsearch, if we encountered any performance issues. I do not know the details of the setup, but I think there were some issues. The indexes we have are in the terabyte range, as far as I remember, and we do not store all the logs that we have generated through history. It just goes 1 month back or so. And Kibana by itself is a JavaScript application. So if you load a lot of data, it may kind of make your browser a bit slow. I don't know how it works on the index side. Perhaps someone of the Allegro guys who are sitting there can give more information. Well, apparently not. Yes?
Yeah, I have the question regarding logging over the network.
Yes?
Because now I'm working, or I
Mhm.
run on several machines. And isn't this logging over internet any problem for performance? Because usually logging could kill the performance if you don't improve early.
Yes, that's a good question. The question is, if you log over the network, does it not cause performance issues for the network? It may. So it does generate traffic, of course, so your network must be able to handle that. And this traffic originates at many hosts, and then it ends up at the logging server. And it also may cause slowdowns in the application itself. So as far as I remember, we set up network logging to be performed asynchronously so that it does not block. Because otherwise, indeed, if there is a spike in network performance, then it might slow down your application, not because of stuff that your application is performing, but because of some logging messages. So yes, you have to pay attention. Yes?
How do you monitor your monitoring system?
Yeah, I mentioned it. I'll be honest, I don't know. We have a team which does that. I haven't asked them about the details, so perhaps you can later come over to our booth and maybe someone else can help. I don't know, honestly. Yes, I think there was another question here. Yeah?
You have in this external logging service Hermes mentioned. What this service is doing?
Well, it was just an example. So the contents don't matter. What matters was that if you put those annotations on a method, then we'll gather performance metrics about calls to that method. It could be just any method which performs some business logic, which retrieves data from database, just anything. So that was just example code. It didn't make much sense. Yes?
Are you using an edge tool to create the releases and like organize it, join it, and deploy those releases, or just scripts?
We have some. The question was what kind of tool we use for deployment, whether these are scripts or some special tool. So we use Bamboo as our continuous integration environment, and we have some custom plugins written in Groovy, which are used to build packages and then to deploy them. Since we have a mixed environment, because we have some OpenStack virtual machines, and we are also moving to Mesos. It handles both kinds of deployments. So it's pieces of custom code plugged into Bamboo. Okay, any more questions?
Probably you have a lot of data from those services.
Oh, yes.
So do you have any messaging? You're just gathering those data and ingesting at some pace of this I don't know, Elasticsearch cluster, which has some capabilities to receive those data.
Essentially.
You use the messaging. So you send the message, for example, to some service, and then you use the messaging to distribute the load on the Elasticsearch cluster when he receives the data from a lot of services.
Well, from the configuration point of view, it's a single address of the Logstash server. Behind the scenes, I think it is clustered somehow, because the load is really large. I do not know so many details, but it is clustered. As I said, you cannot have distributed applications in a cloud and then let them all query a single database which is running on a single box. So everything has to be as distributed as the whole system. So that there is some kind of load balancing going on behind there. Yes?
How long do you preserve the logs?
At this moment, I think it's 1 month. This is reasonably long, because usually if you have to debug some request, it does not happen that something happened a year ago. So again, it's a trade-off between the size of the index, the storage, and being able to debug issues back in time. At this point, it's 1 month. Okay, thank you very much. If you have any more questions or you just want to talk, please come to Allegro booth on level 1. If you want to talk to me, even if I'm not there, you can ask. Somebody there should have my phone and be able to call me. We have a competition running at this address, conf.allegrotech.io. And I also encourage you to read our blog at allegrotech.io. Thank you very much.